identifying design problems in the source code. According to a study of 2014, 25% of discussion in a project are related to design. That happens because soft design is a fundamental concern during the software development process. It's during this discussion that several decisions are made. This decision will drive how the system will be developed. We think then, with that in mind, think about the software system as a series of decisions. So, one might expect that this decision will affect the system positively. However, that is not always the case. For instance, consider non-functional requirements. Sometimes, decisions may have a negative impact on non-functional requirements. When that happens, it's known as design problem. According to the definition, design problem is the result of inappropriate design decisions that have a negative impact on non-functional requirements. For instance, let's consider this image that shows a partial view of a system that manages environments in a university. As a design decision, the developer decides to create a package called service and containing all the classes that access the database. So in other words, all the classes that implement the query concern are inside of this component. However, there are some classes inside of this component that also implement a secondary concern. For instance, institutional enrollment service implement both query concern and management concern. So this is not the only class inside of this component that implement a second concern. And academic enrollment service also implement the management concern. To make the matters worse, there are even other classes like punishment service that implement other concern, like the punishment. So, since this package implements several concerns, there is a design problem there, known as component overload. Design problem happens when a component implements several unrelated concerns. It's a negative impact of this design problem. It hampers the understandability and maintainability of the software system. In fact, design problems are so harmful for the software system that they can lead to the discontinuation of these systems. Therefore, developers should identify and remove them as early as possible. Unfortunately, the identification of design problem is not a trivial task. There are several characteristics of this task that make the identification hard. For instance, systems tend to be large in size and complexity. Usually, the design documentation is unavailable or outdated. In this case, developers are forced to analyze the source code to identify design problem. And analyzing the source code is even more difficult to identify design problem. One of the main reasons is each design problem pervades the implementation of several elements. So in those cases, developers have to analyze several elements to identify a design problem. And in each one of these elements, developers need to find indicators of the presence of a design problem. These indicators, we call them symptoms. And they can be good smells, poor quality attributes, violation of design principles, and developers can use these symptoms to find design problem. However, finding these symptoms may not be easy in practice. I say may not because we don't have much knowledge about how the identification of design problem happens in practice. We do not know which are the symptoms that developers use, how they use and select these symptoms, which characteristics influence how they analyze these symptoms to identify a design problem. In fact, our knowledge is so limited in that subject that we do not know if the existing solutions are aligned with the practice. For instance, most of the solutions focus on proposing or evaluating techniques to identify symptoms and some design problems. But since the knowledge of the practice, we cannot say for sure whether these solutions are aligned with the practice or not. Simply, we cannot even assess these solutions. So, how can we hope to help developers if you have so limited knowledge about how they conduct identification of design problems in practice? So, to tackle this problem, we create our research questions intended to understand how developers identify design problems in the source code. To answer this research question, we conduct a multi-trial industrial experiment at which we investigate how developers identify design problems in the source code. And as a result, we came out with a theory that explains this process. For the experiment, we divided into 4 phases. In the first phase, we select developers and we ask them to answer a survey to characterize them. After that, in the second phase, we provide a training session to ensure a common knowledge base for the participants. And in the third and main phase, we ask the developers to identify the main number of design problems in their own source code in a 1 hour and 30 minutes time frame. And during this task, during this 1 hour and 30 minutes, developers could use any knowledge that they had about the project and all the information that they could retrieve from the source code. For instance, code smells and information about design principles. And using this information, they could identify design problems. Finally, in the last phase, we asked the developers to answer a follow-up questionnaire about the task. And based on this experiment, we were able to collect data and conduct the proper analysis. For that, we can divide the analysis, the collection and analysis of the data in a verbal and written form. In the verbal form, we ask the developers to talk aloud in a freestyle form their thoughts, what they are doing, the reason they did that, why they select that elements, and why they think that there was a design problem there or not. And then we ask them to fill out a questionnaire. And we recorded that on audio and data, which allow us to then analyze using the ground theory procedures. So ground theory is a a systematic method to conduct a qualitative analysis which analyze the data to generate a theory. And ground theory has been used in different disciplines, for instance, medical sociology, management, education. In the last decade, ground theory has been used several times in different studies in computer science. And so after applying the ground theory over the data, we are able to generate the theory that explains the process of identifying design problem. And this is a visual representation of this theory. So our theory contains 15 constructs, 18 propositions, and 27 explanations for these propositions. And all these constructs explain different parts of the identification of design problem. The activity the developer do, when they do these activities, human factors, how they conduct the analysis, the type of symptoms. For instance, in this red box, we can see some constructors related to the symptom. And one of these constructors is how the symptoms are related to each other. In that case, this relation is used, for instance, to analyze the symptom and the element. And during the analysis, the quality of the symptoms and the way that the symptoms appear in the source code influence the confidence of the developer in identifying design problem. Then finally help him to find the problem or not in that element. Unfortunately, I cannot go through all of this construct. However, I will explain a little bit about some constructs related to the symptoms that developers use in practice. We found that developers use multiple symptoms to identify design problems. Code smells, violation of object-oriented principles, poor quality attributes. And this result is interesting because several studies just rely on only one single type of symptom. But we noticed in the real world that is not exactly how developers do. They use multiple symptoms. And another interesting finding that we had was how developers select these symptoms and elements to analyze. As I mentioned in the beginning of this presentation, the identification and the analysis of these elements is not an easy task. But we were able to find the characteristics that developers consider when they have to select a symptom to analyze. Actually, these are aspects that the symptoms and elements contain, and these aspects, we call them characteristics. And we found 6 characteristics that influence how developers select the symptoms to analyze. I'll explain to you, for instance, the frequency of each symptom. So in this case, the developer analyzes each element and count how many instances of that symptom appear in the element. For instance, here about code smells, it appears twice at the student service, and on the other hand, the code smells appears 6 times in the institutional environment service. Therefore, developer will select the institutional environment service to identify a design problem in that element, which increases his confidence about the presence of a design problem. Another characteristic that we observed was about the different type of symptoms that one element manifests. So, different type of symptoms the developer find in an element, more likely he will analyze that element to find a design problem. For instance, a student service has only one type of symptom, the code smell. On the other hand, institutional environment service contain 6 types of different symptoms. So, because of that, developers will focus on that class first, due to the diversity of symptoms in that element, which consequently increase his confidence about the presence of a design problem in those elements. So it was a really nice result to find these characteristics, as I mentioned, 6 of them, and how they influence how developers analyze the source code. But a good result about this knowledge is how we can use this knowledge to improve the state of the art. For instance, we can use these characteristics to propose heuristics to automatically select symptoms that are likely to help developers to identify design problems. So this is one type of study we can conduct in the future, based on the knowledge provided by the theory. Another interesting result that we had was, after developers selected these symptoms, how they analyze them. And we found that developers combine multiple symptoms to identify a design problem. And as an example of this combination, let's go back to that picture. And here, when developer was analyzing this class, he noticed that the class was hard to read and to understand. And he decided to find the reason why it was hard to read and to understand. And he found that the class had a high coupling and low cohesion. And when the developer analyzed the class, he noticed that some of the methods in the class had different type of code smells. For instance, feature envy and intensive coupling. And these smells appear in the class because the class was implementing 2 unrelated concerns, consequently violating the single responsibility principle. So each one of these 5 symptoms add information to help developers to identify a design problem in that component. But additionally, the developer noticed that all these symptoms appeared in other classes as well. And this was the reason that helped him to identify the component overload in that package, since all the other classes that was implementing more than one concern containing these symptoms. And now that we know how developers combine these multiple symptoms, we can also propose solutions to help them during this task. For instance, we can create a heuristic to find symptoms that can be automatically combined. And in this way, we can reduce the effort that developer has to identify and combine the symptoms. So this is another type of study that we can conduct based on the knowledge extracted from the theory. And just to conclude, we know that software engineering is a recent area and we need theory, and this was a contribution for the field. And based on this theory, we can describe the activities, factors, characteristics, and steps that influence how developers identify design problems in the source code. And not only describing the theory, but we can also use this theory to improve the state of the art. For instance, creating solutions, techniques that can help developers to identify design problems. So thanks so much for listening, and now I can take your questions.
Michelle, is that microphone?
Thank you for a nice talk. Thank you for a nice talk. There's work in using software metrics for identifying design flaws in source code. One of the issues there is they generate many false positives. So apparently one of the things that developers do is do some type of prioritization or selection of design flaws. Could you comment if you found any evidence how they do this prioritization?
Yes. So these two characteristics that I mentioned, there are four more, and the developers combine these characteristics to prioritize elements that appear this characteristic a lot. For instance, if one class contains different types of symptoms, and these symptoms are related to each other, and they contain different instances, they use this information to prioritize that element. But they also had all the strategy to prioritize elements. For instance, they prioritize elements that are core in the system. They prioritize elements that they know that if they touch in that element, will have an impact on all the non-functional attributes like performance or maintainability. So you are able to find different different strategies that developers use to prioritize the elements and symptoms to analyze.
Question over here.
Right. You used a training session before you conducted the experiment. How did you avoid biasing the developers, that they now think very strongly about code smells, for example?
Good question. So, in this, we'll make sure not to bias the developer. It's not saying, for instance, you should do that or should do other thing. We didn't say that. The training was only to make sure that all the participants were on the same page. If they knew about the technology, if they knew what is the main reason of the task. So we did try to not influence them as many as possible. Of course, there is always a threat to validity on that case, but in this training session, our main goal was try to make sure that everybody had the same knowledge about the terminology and the task.
Okay, we'll still take another question if there are any more questions. I have a question about the methodology. So it's a qualitative study, so I'm kind of curious that you did it kind of as a controlled experiment. I mean, did you consider actually going into companies and doing kind of observational studies? That's the more normal thing to do if you're doing grounded theory in a qualitative study.
Oh, yeah, sorry. In our case, we actually went to the company and we observed them working for a while, and we tried to understand how was their daily work, and based on that, we ran the experiment in the company and asked them to work on the source code, to maintain the source code in the same way they do in the daily basis. So was exactly going to the company and ask them to work in the source code. The only difference was you have a task is to define that problem, but was actually observing them in practice, doing the task.
But was that data taken into account in your grounded theory analysis?
Yes.
Oh, okay, great. All right. Thank you very much. Oh, there's one question here.
Yeah, it's sort of as a follow-up of that. My question is, what do you think triggers the task of finding design problems? Because in your experiment, you told them go find them, right?
Yes.
Is it the case that they would find that there's all these symptoms and then they go to look for problems, or something else?
We also try to understand what triggered them to find design problems, and we are able to find some aspects that trigger the identification. One of them was